Here is a concise one-line definition of squaring a number. To square a number, just multiply it by itself. Squaring numbers has several applications. It's used to find the area of a square, equilateral triangle, and in the famous Pythagoras theorem, among other applications. In this video, we will look at some special scenarios that will help in squaring numbers quickly and mentally. Here are some examples we will be looking at in this video. Does this look intimidating? If it does, then our goal is to make you feel otherwise by the time you are done watching this video. So let's jump right in and look at our first example. What is 65 squared? Here's the first point you need to bear in mind. This is a number ending in 5. And here is how we square such numbers. First, focus on the 5. What is 5 squared? It's 25. We write this down. Now focus on the remaining numbers. In this case, it's just one number and it's 6. What number comes after 6? 7, right? We then find the product of 6 and 7. 6 times 7 is 42. Combining both results, we get 4,225, which is the correct answer. Let's try another example to reinforce the concept. What is the square of 85? Having noted that the number ends in 5, we use the same logic as before. We first square 5, that gives us 25. We then multiply the first digit and the digit that follows. The first digit is 8 and the digit that follows is 9. And 8 times 9 is 72. Combining the two numbers, we get 7,225, which is correct. So does this method work for bigger numbers? Let's test it out. What is 105 square? The second part of our answer is 25. For the first part, we multiply 10 and 11, which gives us 110. Our answer is 11,025. Do feel free to check the answer, please. So will this logic work for even bigger numbers such as 1,195, you ask? Yes, it would. So the second part of our answer is 25. And for the first part, we would need to multiply 119 and 120. Now this may appear like a lot of work, but it's certainly easier than multiplying 1195 with itself. And we do have a video that will help you to find the result quickly. So do stay tuned. Now that we know how to square numbers ending in 5, let's reuse this knowledge for two other scenarios. What is 86 squared? 86 is one more than 85. So it's pretty obvious that the square of 86 will be bigger than 85 squared. But let's first find the square of 85. The answer is 7,225. And to find 86 squared, all we do is add the sum of 85 and 86 to this result. So our final answer is 7,225 plus 85 plus 86, which is 7,396. We can use something similar for finding the square of 84. 84 is 1 less than 85, so 84 squared will be smaller than 85 squared. As before, we first determine the square of 85, which is 7,225. And we then subtract both numbers, 85 and 84, from this result. So our final answer is 7,225 minus 85 minus 84, or 7,225 minus 169. This gives us 7,056, which is the correct answer. Now let's turn our attention to another special case of squaring numbers. We will look at squaring numbers close to 10 100, 1000, 10,000, etc. Please make a note of this. So here is our first example. What is the square of 93? As you can see, 93 is close to 100, which we will call our base number. The first question you need to ask is, how close? 93 is 7 less than 100. Now we do two things. Since 93 is less than our base, we reduce it by the deficit. 93 minus 7 is 86. We then multiply this result with the base. 86 times 100 is 8,600. We then find the square of the deficit. 7 square is 49. Now to get our final answer, all we do is add both results. 8,600 plus 49 is 8,649, which is our final answer. Let's try another example to reinforce the concept. What is 92 squared? We first find our base. 92 is close to 100, so our base is 100. We then find the deficit. 92 is 8 less than 100, so our deficit is 8. Since 92 is less than our base, we reduce it further by the deficit. So 92 minus 8 is 84. We then multiply this result with our base. 84 times 100 is 8,400. We then find the square of the deficit. 8 squared is 64. And finally we add both results. 8,400 plus 64 is 8,464, our final answer. You may have noticed that both 93 and 92 were smaller than 100, our base. So what happens when our number is bigger than the base? Let's find out. What is 103 squared? We first find out our base. 103 is close to 100, so our base is 100. We then find the difference between the two. 103 is 3 more than 100. Since it's more than our base, we call it a surplus of 3. And we add the surplus to our number. This is an important step, so please make a note of this point. We subtract the deficit and add the surplus. So 103 plus 3 is 106. We then multiply this result with our base. 106 times 100 is 10,600. We then square the deficit. 3 square is 9. And finally we add both results. 10,600 plus 9 is 10,609, our final answer. Now that you have grasped these concepts, let's try squaring a bigger number. What is the square of 997? So then, what is our base? 1,000? Yes, I would agree. What is the deficit? It's 3, right? Since 997 is less than the base, we subtract the deficit. So, 997 minus 3 is 994. We then multiply this result with 1000, our base. 994 times 1000 is 994,000. We then square the deficit. 3 squared is 9. And finally we add both results. 994,000 plus 9 gives us 994,009, our final answer. Now imagine if you had to solve this problem using the conventional method. It would surely take much longer, wouldn't it? I now wish to discuss one last point before concluding. I stated at the beginning that this method could be used to square numbers close to 10, 100, 1000, etc. So how close is close? Let me demonstrate. What is 56 squared? So 56 is close to 100, which is our base. The deficit is 100 minus 56, which is 44. As before, we subtract the deficit from our number, since it's less than the base. 56 minus 44 is 12. We then multiply this result with our base. So far so good. We then need to square our deficit, which is 44. So what is 44 times 44? That isn't easy, right? So, as a rule of thumb, when you're using this method, ensure that the deficits and surpluses are small enough so that you can square them mentally. So this brings us to the end of the session. I hope you found these methods useful. Please complete the exercises that are part of this lesson. Thanks a lot, guys, and see you in the next session.